Please let me know in the chat box. Yes, yes. So let's start this session. So let me share my screen. Give me a second. I hope everyone has got access to the Google Drive and you can able to watch the recordings and can able to open the document and all right. Yes, that's great. And I hope you have once seen the document which I have shared in the I mean the Google Drive. So please once look into the document which I have shared in Google Drive so that it will be easier like what I'm discussing in the session, right? So if you have once watched once reviewed the document, then it will be clear to understand what I'm discussing in this particular session, right? Yes. So how many is there anyone who cannot able to access the drive? Is there anyone like that? Please let me know in the chat box. And if you cannot access the Google Drive, you can do one thing. You can just click on the link and you can just request access. You can send me the request access so that I will accept it from my end so that you can able to access the Google Drive. And in that only all the recordings, PPTs, and like all the documents which are related will be uploaded in that. Okay. Yeah. Now let's start this session. One second. People are joining. Okay. So let me share my screen. Where is this? Yeah. So as we are designing an SOC and verifying an SOC, so it will be not a good thing like if we don't know the simple definition of what do you mean by an SOC. So basically, SOC is a system on chip and it is a complete electronic system integrated into a single IC. So where instead of having separate chips for CPU, memory controller, UART, and etc., we are going to integrate them everything onto a single chip. That is nothing but my system on chip. Okay. So here, in the case of my system on chip, I'm going to have different kind of uh, controllers, peripherals, everything will be connected via some protocols that we are going to refer to. And this is ARM SoC architecture, which is basically given by Texas Instruments, and this is how it is going to look like. When I'm going to show you Vivado also, I'm going to show you the Zinc architecture and ARM architecture, where we are going to have the processor which is connected via the interconnects with the peripherals and shared memories and all GPIOs and all. Okay. So like this kind of thing, we are going to replicate this kind of architecture. I will show you like how we are going to replicate and what do you mean by interconnect and all. Okay. So this is nothing but my an associate. We are going to basically try to replicate this kind of architecture. And our journey has started with implementing this GPIO. So this basic block, we are going to start with discussion. Okay. Now, so basically, GPIO stands for General Purpose Input Output Board. Now, if you might work with some hardware like Raspberry Pi or Arduino or FPGA, if you have, you might have seen this kind of pins which are present in any hardware circuit. These are basically for transmitting the data or receiving the data with your peripheral devices. Okay, so one second. So these are nothing but my GPIO pins. So this GPIO pins are basically used to connect with my peripheral devices. Okay. So you can think of any sensor or you can think of any particular display or you can think of any particular external hardware you're going to connect. This is how you're going to use and these are basically the pins you're going to use, general purpose input output pins. And each particular pin will have some kind of functionality. Like if you're working with the Arduino board, you might have seen it like why I'm taking always Arduino board example because many of you have might work with it because it's very cheap and it's like 500 bucks to 450, right? So if you want to buy an FPGA, it will be like in thousands, like 50K or 40K or then might 15 or ranging from 15 to 20, 40K. So that's the reason I'm basically mentioning about Arduino boards So in your Arduino boards, you might have seen some kind of pins, which is basically for analog to digital pins or ADC pins or some kind of pins. Those are all also GPIO pins. Now, how we are going to set the functionality on and all that we are going to see. So this is nothing but my GPIO pins. So basically GPIO, which stands for General Purpose Input Output Peripheral in an SoC or a microcontroller, is mainly controlled by a set of memory mapped registers. So this is a very, very important term, both in terms of embedded and VLSI. So embedded people are going to use it a lot, which is nothing but memory mapped registers. So what do you mean by memory mapped registers? In a few seconds or in a few minutes, we are going to see about this. Now, this particular GPI IP is going to have some kind of registers. This registers, the functionality of this registers is to configure the pins as input or output. For example, here we are having some pins, right? So we are having this kind of pins which are present over here. Now, for configuring this pin, whether it should act as an output or whether it should act as an input. So how we are going to configure it? That we are going to configure it using this particular IP, and in this IP is going to have some kind of registers, and we are going to use it registers and we are going to configure it, and we are for reading the external signals and for driving the output values, for configuring the interrupts and for selecting alternate peripheral functions. So these are the different functionalities of our GPIO IP. Okay, now let us see one example and try to understand what is this functions and all. So let's say if I'm going to have some pins like this. These are my GPIO pins which are available on my hardware, right? Now, let's say I have a particular controller. This is my GPIO IP which is present, and this is my hardware which is present. Okay, so this is my hardware, and these are my GPIO pins which are present, and this is my GPIO IP or some IC which is present over here. Now, this particular, whatever the component or IC which is present, this is going to control your pins. One second. So this particular IP is going to control whatever the pins you are going to have, right? This particular IP is going to control them. So that's why this is known as controller. Okay. So we need to program this controller. Now, embedded people, what they are going to do is they are going to write down an application code and they are going to access something known as registers over here. So as I've said, right? So GPIO IP is going to have some set of registers like this. So let's say I'm going to have one, two, three, four, five registers like this. And where are these registers present? These registers are present inside this particular IP, GPIO controller IP. This particular registers are present. Now, if one embedded person is going to write down an application, he is going to write down an application in C language or C++. And what he's going to do, let's say, suppose if this particular GPIO IP is connected to some pin, some external pin. Let's say these are some external pins, male pins, which are present on the hardware. These are some external pins which are present. Now, let's say this is pin number P1, this is pin number P2, P3, P4, and P5. And these pins are being connected to this particular IP like this. Okay. Now, let's say if I want to configure this pin 1 to be an output pin, and let's say if I want to configure this pin P2 as an input pin and remaining all three other pins as an output pins, I want to make this configuration. So in the application side, what the user is going to do or what the coder is going to do is he's going to first of all he's going to check he's going to have some kind of data sheet. Yesterday TRM, have you seen, anyone has seen the TRM of GPIO? Anyone has seen the TRM of GPIO which I have shared? Yes. Have you seen any kind of registers or register addresses? Okay, not an issue. I will once explain and once you can go through the TRM and once you can check. So, what is going to happen is in the TRM or any particular technical reference manual he is going to get, and in this particular document, he is going to have, let's say, this register is basically used to configure the direction, and this another register is basically used to store the data temporarily, and this register is going to control the interrupt. So like this, for different functionalities we have different kind of registers. Okay, now let's say we are talking about this direction. Let's say if I want to configure this pin 1 to be an output pin, and pin 2 to be an input pin, and pin 3, pin 4, pin 5 to be an output pins. This is what I want to make the configurations. So what the coder or what he is going to do is he is going to first of all check into the